Today's set of notes is going to build on the idea of the area of a circle. So we're going to review the area of a circle first. Those are going to be the first couple problems on your homework tonight. So let's show you what that looks like. This was on your last test. This is not new. This formula is on the formula sheet. So literally everything is going to build off this formula that is provided to you. What you'll need to know is what to add or subtract or multiply by to get the other types of shapes. So starting off with, the formula is pi r squared. Again, that one's on your formula sheet. So to do the area, it's going to be equal to, now before I start, I'm going to say this again. If I was taking the test, I would go through every single circle and I would take every single diameter that I have and cut them in half and make them radius before I do anything. That means for problem number 2, I would change this to what? What would the radius be if the diameter is 25? Put 12.5 on that one. And then I would go to problem number, let's see, no, oh, there's one. Problem number 4, I would cut that in half. If the diameter is 20, what would the radius be? 10, bless you. 10. Then I'm going to do it again, and I'm going to go to the next set. That's a radius, that's a radius. Let's see, radius. Ooh, there's a radius and a diameter here that we need because we do need the side length. But if the side length is 10 here, what would the diameter of this circle be? 5 inches. And what would the if the diameter right here is 16, I'll get the word to come out, what is the radius going to be? 8 inches. Now that would be, like, I'm serious, if I was taking this test, that would be the very first thing I went through and did on this entire test. Because if you use radius, it'll all work. If you use diameter on circumference, it'll work, but if you use diameter on any area problem, it will not work. So I would go through and cut those in half before I did anything. Now let's go back to doing our problems, guys. Here we go. Our formula is pi r squared, so our formula is going to be pi, that's not looking like a pi symbol, pi times 4.3 squared. Okay. Grab your calculators. Alright, it's going to be 4.3 and hit the square button, guys. There's no second, no nothing, we're not taking the square root, we're squaring it. So you type 4.3, hit the square button, and you're going to round to 1 decimal place. What's that give you when you round that to 1 decimal place? 18.5 pi meters squared. You got to have the pi symbol or it is incorrect. Guys, 18.5 is not really 18.5 when you got the pi symbol behind it. 18.5 pi is really, let's see, approximately 58.09. That is not really 18.5. It's 18.5 times 3.14, but we leave it with the pi symbol so it's more exact. Okay, let's do the next one. Pi times 12.5 squared. Okay, grab your calculators, multiply 12.5 squared. What's that give you rounded to 1 decimal place? 0.3. Do y'all agree on the rounding on the 156.3? Okay, and that is inches squared. Anybody have a problem typing it in? Anything, guys, you got to know how to type these. If you can't type them, it doesn't matter at all. You got to be able to use these calculators. Okay, here we go. The next one, guys. The biggest problem with this is people are not going to look at the picture and make sense of it. Okay? This next one is called a sector. Guys, every single one of these is like a pizza where they've taken away part of the pizza. Okay? So instead of doing the whole pizza, you're now only going to be doing part of the pizza. So we're still going to use the area formula, which is pi r squared. But just like when we did arc length, we're going to multiply it by however many degrees it is out of how much? 360. There you go. By the number out of 360. Exactly correct. Now, before I do anything, guys, the biggest problem that people have is knowing which of these numbers to use. Okay, are you using the 88 or do you need to find the other part of it? It's wherever the shading is. So look on these 4 problems. There's only one where the number is already in the shaded area. Which example number has the number that you need already? It's example number? Not 6.
No, 4.
Example 4. Why is 4 the one you need? Because it's already in the shaded area. Do you see that these 3 are all in the whited out part? That's not the shaded area. That means we need to find this number over here. To do that, guys, every single time it's just 360 minus that number. Do that subtraction real quick. What does that give us for this shaded area right here? 272. Okay, then we're going to do it again down here. 360 minus this 162 is going to give us what for this one down here? I want the shaded area part of the example number 5. 198. I always thought it'd be, oh, okay, because it'd go past it. And then the last one is going to be 360 minus that 15. I can do that one in my head. It should be 345, right? Okay. Does anybody have a question where I got those numbers from? Guys, if our number was in the shaded area, do we need to subtract? No, it's already in the shaded area. You don't need to subtract if it's in the shaded area. Okay, here we go. Area equals, you do the exact same thing you did before, pi times the radius squared. The radius is 7 squared times the number out of 360. What number out of 360 are we using? 272 out of 360. Grab your calculators. Now, if it gives you a fraction, put a fraction. If it gives you the decimal, use the decimal. You can convert it if you want to, but there's no need to. I will take fraction or decimal answers. So, grab your calculator, type 7 squared times 272, fraction button, 360 equals. Now, it does give you a mixed number, so hit second fraction button equals. It's a large fraction. What does it give you on top? That's not what I got.
Yeah, I got 1666.
1666 over 45 pi, and that would be meters squared. Where was it? I'll talk through it. Where do we need to go? We need to type it? Okay, let's type it again. Here we go. Clear it out. Let's make sure. 7, hit the square button. You might not hit squared now that I'm thinking about what the number was. 7, hit the square button. That's the little x2. It's the one that looks like this. No second, no nut, just 7 squared times 272, fraction button 360 equals. Then second fraction button equals. Does anybody still have a question about that? Okay, here we go again. The next one. This is going to be area equals pi times 10 squared times 180 out of 360. Now guys, think about this. What is 180 out of 360 like multiplying by? 0.5 or 1/2. It doesn't matter. It's like half of it because you're taking half the circle. So what is that? It's actually a nice number. It's a nice whole number. Some numbers are nice. 50, 50. Okay, 50 pi, and this would be inches squared. 50 pi inches squared. Anybody stuck, concerned? Because we got 4 examples. We got a lot of this just to make sure you know how to do this before we move on. I think you have less problems than that on your homework. I think you only have 2 we're doing on the homework. We're doing a lot just to make sure you got it. Okay, the next one has a decimal in it because you might get a decimal answer. Here we go. Area equals pi times the radius, which is 5.4 squared, times the number out of 360. Which number do I use out of 360? It's the 198 in the shaded area, wherever the shaded area is. Okay, guys, do the math for that. 5.4 squared times 198 fraction button 360. Now that's going to give you a decimal that you need to round off to one decimal place, but is this the one that rounds weird? It's just 16 or 6? 16? Okay, I'm hearing two different answers. So 16? Oh, is it 6? You mean the last number 6? That's what you're trying to tell me. So 16 pi, and that is meters squared. It's like 16.0 something. Yeah. And since that number 03? 8. There you go. So since the 0 is behind here and there's a 3 after, it would round to 16.0. If you wrote 16.0 pi, I'd give you credit. It's the same thing. I don't care, guys. Just get it on there. Anybody see anything about that before we do our last one? Okay, get an answer to that last one, guys. I'm not even going to write it out so y'all get an answer. It's a fraction. It's just a big fraction. I don't care if you give me the decimal or fraction for any of these. I don't care at all. On my test, I just made the test keys for this chapter, and I put every problem, I put the decimal and the fraction answer on, so that in case anybody does it either way. I don't think that's big enough. My number's much bigger than that. What's 29, guys? 29 is the what? 15? Oh, okay. Change it real quick. Don't let them get it before we put an answer, and try typing it again. 15 is the angle. We don't use the angle in there. We're using that radius. The radius is 29. Be careful when you set that up. So it'd be pi times 29 squared times that 345 fraction button 360. Second fraction button equals, and what do you get now? What did y'all have? The ones that y'all, anybody that's got that? 343 all over what? 24, and that would be pi millimeters squared. Ooh, that's a big number. Better now? Does that work for both y'all? Okay. That's interesting to know where you got it from. That's what, same thing. Yep. Be careful. Make sure you use that radius. Anybody see anything before we move on to the next type of shape? Now, listen to me. This next one, why they call it a segment doesn't matter at all. I will tell you that no one's going to remember the name, I'll be honest with you, because it bothers people that it's called a segment and it's not shaped like a line. However, I will tell you that there is an easy way to remember this formula, and it's going to use that triangle y'all liked. Here we go. Okay, guys, it's the area of a sector, just like we did before. So it's still pi r squared times the number out of 360. That's not going to look like a 6. Hold on. 360. But, see, this whole thing was here. That would be just like the ones we just got done with. But they took the triangle and they whited it out. Guys, when you take it and white out the triangle, are you going to add the area of the triangle or subtract it? Subtract it, because we're taking it away. We're whiting it out. So we're going to subtract that. So we're going to minus, and then we need a formula for a triangle that uses the angle and trig. You know this formula because we just did it on those worksheets. Y'all said, oh, these are the easy problems. I can do this. It is 1/2 BC sine of A. 1/2 BC sine of A. Guys, listen to me. I'm going to show you this picture and we're going to talk about it. This is your triangle right here. Don't write on this. I'm just showing you this. Just watch. Here's the triangle. Okay? These two sides are your B and your C. See how they're on either side of that angle? If this side is 24 and it's a radius, then this side, which is also a radius, also has to be what? 24. And then we use the sine of 120. Alright? Here we go. Let's do a problem. Area equals pi times the radius, which is 24 squared, times, guys, how many degrees is the shaded area in? 120 out of 360. But now we got to get rid of that triangle, so we got to do minus 1/2 Guys, do y'all understand the BC is the same thing as the radius squared again? You can write it as 24 times 24, or you can write it as 24 squared. I don't care. It's the same thing. Doesn't matter. 24 times 24, which is 24 squared, times the sine of 120. Now listen. Don't make this complicated. These are separate and they are going to stay separate. Do this exactly like you did the last problem. Area equals, do 24 squared times 120 fraction button 360. It's actually a nice number. 192. Do y'all agree on the number? Try it. Hold on. Let them get there. I want to make sure everybody gets that. Did y'all get 192?
Yeah.
Yes. So 192 pi minus, then you do the other half on the calculator. 1 fraction button 2 times 24 squared times sine 120 equals. No, because the sine 120 is at the end, so it doesn't matter. You could, but it doesn't change the outcome. 249 point what when you round it? Whoa, final answer, so 0.4. This is the final answer. Why is this the final answer, guys? This one has a pi in it, and this one does not. Can you subtract those? No, it's like having an x in it. Can you subtract 5x minus 3? No, you can't put those together. This is the final answer. So we put meters squared at the end, and you are done. That's it. Don't make that harder than it is. It's the same thing. That's two things that we've already done. We did that one just a minute ago, and that one we did last week. We've done these. Alright, here we go. Let's do it again. Area equals pi times what is the radius? 10 squared. Times what is the angle out of 360? What does this symbol mean, guys? 90. That's what that means. 90 out of 360. 90 out of 360. Minus 1/2 times, guys, B and C are the sides of the triangle. They are also the radii. So you can just write times 10 squared times the sine of 90. Okay. Both these turn out to be nice numbers. Try multiplying the first part. Don't say it if you know it. Don't say it yet. Let somebody try it. Hold on, I got an email I gotta look at. What's it say? Okay, what's the first part of this? 25 pi minus, what's the second part of that? 50. Okay, and that'd be inches squared. Does anybody need me to type either part of that? We're good on that? Okay, guys. Okay, look at the next pictures. Okay, what is the difference between, everybody sees example 7 and example 8, between 7 and 8 and 9 and 10? Hold on, wait, well, I've got different words, but I couldn't hear it anywhere. What's the difference? Help me, tell me again, sorry. Yeah, we're still looking for shaded area. We were doing that last time. It was a segment before. Now we're looking for the shaded area. It doesn't have a special name. But what's different, guys, about the triangle? It's shaded in. Thank you. It's shaded in. And since the triangle is shaded in, what's the only difference between this formula and the last one? It's addition. You're adding the triangle instead of subtracting it. You are going to add the triangle instead of subtract it. It's the only difference. Here we go. It is pi r squared times the number out of 360. But instead of subtracting the triangle, you are adding it. Najan, join us. You're going to miss this. Come on, we got brand new formulas. Come on. It's going to be 1/2 BC sine of A. You're adding that triangle in. Now listen, there's one other thing that messes people up on this one. And this is the last one of these before we do two easy problems. It's the last two, they're circles, because they always end up on the EOC and I've got them on the worksheet. But these are the ones that people mess up because of this. Look, look, look. This shaded area does not use the same angle as the triangle. You see the triangle has the 88 in it. That's not going to be the same number as this. To get this number, you have to do 360 minus that 88. What does that give you? What was it? I'm sorry. 272? Okay, so this is going to be 272. Guys, you're going to use 272 for that main part, and then you're going to use 88 for the triangle. Okay, for the sign. Yes, is correct. Okay, so here's the formula. This is what it looks like. Area equals pi times the radius. Guys, which number out of these is the radius? 7 squared times how many degrees out of 360 for the shaded part? Not the triangle, the shaded part. That's the 272. Plus 1/2. BC, guys, it's just the 7 and the 7, so it's 7 squared times the sine of what? 88. Nice. Nice, 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 nice. Okay, guys, do the multiplication. I think we actually already did this one time before. I think it's like on one of the first examples we did. Is the very first one? So is that the 1666 over what? 45 pi. The second half, though, is different. So what is it when you multiply 1/2 times 7 squared times the sine of 88 and round to 1 decimal place? I don't have this, so I don't know. What was it again?
24.485.
So 24.5? Okay. And that would be meters squared. Nice. Okay. Last one of these, then we just have the circles and the squares. They love those problems on the EOC, so I always make sure to hit those. Most people can do them without going over it, but I like to make sure I see them. Okay, guys, here we go. Last one of these. Pi times the radius, which is 11 squared, times what out of 360? 330 is the correct number. Guys, this is the area we're talking about. We have to do that 360 minus the 30 leaves us 330 for the shaded area out here. This is 330. I didn't do it ahead of time because I wanted to see if somebody would catch that, and they did. That's awesome. 330 out of 360 plus the triangle, which is 1/2 times 11 squared times the sine of what angle? 30. 30. That's what goes in the sine. Nicely done. Okay, guys, I don't have the answers for this one, so I don't know whether this number's nice or ugly or anything else. Is this ugly? Y'all are making faces. What is 11 squared times 330 fraction by 360? What's that fraction? 31 over 12. Ooh, I gotta type it because I got people making faces at y'all. Let me type it. Y'all know I'll back you up and see if you're right. So it's gonna be 11 squared times 330 fraction button 360 second fraction button equals 1331 over 12. That's what I got. Okay, and that would be pi plus what y'all get for the second part? 30.3, and that would be meters squared. There we go. Okay, guys, last two. What shapes are we dealing with in these last two problems? What shapes are there on those last two examples for 11 and 12? Squares and? You all understand that they're both squares and circles. Even though that second one is a circle that's cut in half, So this is a square and a circle. Would you be adding or subtracting that circle? Is it whited out or is it shaded in? Whited out. So if it's whited out, do you add or subtract? Subtract. So we're going to subtract. So it's going to be the area of a square, guys. The area of a square formula is side squared. And we're going to subtract the area of a circle, which is pi r squared. That's not anything new. We've done both those formulas before. The only difference is that you need to know to subtract them. Okay, here we go. What's the side length on the square? So 10 squared. And we are going to subtract the circle, so it's minus pi times what is the radius? 5 squared. Okay guys, y'all should know this. What's 10 squared? 100. Minus what's 5 squared? 25. Put the pi behind it. It's inches squared, and that is your answer. Why can't I go any further? Because they are not like terms. They're not the same. I can't combine them. I cannot subtract something with a pi with something that doesn't have a pi on it. You cannot do that. You've got to keep it just like that. Okay, let's do it again. Guys, y'all understand this is really just a square and a circle. They just happen to be, they just flip the two sides. That's all it is. Still the exact same formula. It's still going to be 16 squared minus pi, times what squared? 8 squared, thank you. 8 squared. Let's see if I can remember. 256?
Yeah.
256 minus 8 squared would be 64 pi, and it'd be inches squared. Nice. Okay, guys. Anybody see anything? Have any questions? Anything about it? Okay, like I said, the assignment